Welcome to this tutorial on color vision and interactive PhET simulation. In this tutorial, we will demonstrate color vision and interactive PhET simulation. Here, I am using Ubuntu Linux operating system version 16.04, Java version 1.8.0, Firefox web browser version 60.0.2. Learners should be familiar with high school physics and biology. Using this simulation, we will look at color vision when the human eye sees white light, light of different colors from the visible spectrum, light and filters of different colors of the visible spectrum, red, green and blue light separately or in combination. Please refer to the additional material provided with this tutorial. Let us begin. Visible light. A portion of the electromagnetic spectrum is detected by human eye as visible light. This portion extends from 380 to 760 nanometers. The colors of the visible spectrum can be remembered as VIBGYOR: violet, indigo, blue, green, yellow, orange, red. The lowest wavelength, highest frequency, appears violet. The highest wavelength, lowest frequency, appears red. Combining all the colors gives white light. Use the given link to download the simulation. I have already downloaded the color vision simulation to my downloads folder. To open the simulation, right-click on the color vision HTML file. Select the Open with Firefox web browser option. The file opens in the browser. This is the interface for the color vision simulation. Now we will explore the interface. The interface has two screens: single bulb, RGB bulbs. Click on single bulb screen. In the single bulb screen, you can see a person facing the right. Just below the neck are two small images. The first one is highlighted. It allows you to see the person's face. Click on the second image. On being highlighted, it shows the cross-section of the person's brain. Observe the optic nerves extending from the eyes into different parts of the brain. Color vision. Cone cells are photoreceptors in the retina that are sensitive to a range of wavelengths. The leaf absorbs all wavelengths of visible light except green light. Green light of 520 nanometers wavelength is reflected and reaches the eye. Here it activates the M or gamma type cones. The visual information is sent from cones to retinal ganglia via the optic nerve. The two optic nerves meet and cross over each other at the optic chiasma. Now called optic tracts, they enter and synapse in the thalamus. They then continue to the primary visual cortex in the occipital lobe in the back of the brain. Let us return to the simulation. Observe the ellipses above the person's head. They will be filled with the color that the person sees. Note the play/pause button at the bottom and the step button next to it. The reset button will take us back to the start. Observe the torch or flashlight in front of the person's eyes. The red button on the flashlight will switch it off and on. Click on the first bulb above the flashlight. This is white light. Click on the red button of the flashlight. The first image below the flashlight is highlighted by default. This will show the light as a beam. Click on the second image below the flashlight. This will show the light in the form of photons. Click on the pause button. Observe that the step button is active. Click on the step button to see the photons move in a stepwise manner. Click on the first image to return to the beam from the flashlight. Observe the white ellipses above the person's head. This means that the person sees white light coming out of the flashlight. Click on the second bulb above the flashlight. Observe the slider bulb color containing all colors of the visible spectrum. Drag the bulb color slider from end to end. The color on which the handle is placed indicates the color of the light from the flashlight. Observe that the ellipses above the person's head fill with the same color. You can change the color that the person sees by dragging the bulb color slider. Drag the bulb color slider to red at the right end. Note that there is a toggle switch in front of the person. It is connected to the filter color slider. Observe that the filter color slider also contains the colors of the visible spectrum. Click on the toggle switch. Observe that a filter appears in the path of the beam from the flashlight. Drag the filter color slider from end to end. The color on which the handle is placed indicates the color of the filter. Note, the filter is red and transmits a red beam. The person also sees red light. Drag the bulb color slider to violet. Violet light comes out from the flashlight. But with red as the filter color, no light is transmitted to the person. The person does not see any light. Drag the filter color slider to violet at the left end. Note, the filter becomes violet and violet light is transmitted to the person. The person now sees violet light. Drag the bulb color slider to red at the right end. Observe how the filter remains violet, but the light beam is now red. But the violet filter does not transmit the red light. The person sees no light. Drag both sliders to different colors to see whether light is transmitted to the person. Observe how light is only transmitted when both sliders are set at the same or nearly same color. The filter subtracts all wavelengths and only transmits the wavelength of its own color. Transmission is weaker for wavelengths very close to and maximum for the filter's color. As an assignment, choose white light to come from the flashlight and observe the transmission of light from the filter. Now let us click on the RGB bulbs screen at the bottom of the interface. Here too, you can see the person facing the right. Click on the second image, which allows you to see the cross-section of the person's brain. The play, pause, step and reset buttons are all seen at the bottom of the interface. 3 sliders and 3 flashlights are seen on the screen. All sliders are set at the minimum levels. The uppermost one is a red slider. The second, green, and the lowermost one is a blue slider. Drag the red slider to the maximum level. Note how red photons come out of the flashlight next to the red slider. The photons reach the person's eye and the person sees red light. Drag the green slider to the maximum level. Note how red and green photons come out of the flashlights next to the red and green sliders. Red and green add to give yellow. The cones sensitive to red and green light are activated so that the person sees yellow. Click the pause button. Drag the blue slider to the maximum level. Click on play button. Observe how all three colors mix so that the person sees white light. Let us summarize. In this tutorial, we have demonstrated how to use the color vision PhET simulation. Using this simulation, we looked at color vision when the human eye sees white light, light of different colors from the visible spectrum, light and filters for different colors of the visible spectrum, red, green and blue light separately or in combination. As an assignment, adjust the red, blue and green sliders to get these 6 colors. Which RGB combination would you pick to design these schemes? Look for an image of the color wheel on the internet. Pick color combinations for the following schemes. The video at the following link summarizes the spoken tutorial project. Please download and watch it. The Spoken Tutorial Project team conducts workshops using spoken tutorials and gives certificates on passing online tests. For more details, please write to us. Please post your timed queries in this forum. This project is partially funded by Pandit Madan Mohan Malviya, National Mission on Teachers and Teaching. Spoken Tutorial Project is funded by NMEICT, MHRD, Government of India. More information on this mission is available at this link. This is Vidya Iyer from IIT Bombay signing off. Thank you for joining.